Anything worth doing is of course worth overdoing. So today we're going to over-design a Toolpost dial indicator holder for the lathe. Welcome back to Cloud 42, I'm James. Last week we got started working towards a Toolpost dial indicator holder for the lathe. We took some detailed measurements and made a 3D model of the dial indicator that we're going to use. And this week we're going to design and prototype the holder itself. Now, some other creators here on YouTube have made dial indicator holders for the lathe. Mr. Pete did a series about a year back where he did one. And there's lots of good designs out there to choose from, but the caveat is they won't actually work on my lathe. I don't have as much clearance over the compound on my lathe as on the lathes that some of the other creators have been using, and so I'm going to have to take a different approach. Okay, when I say that space is tight on this lathe, my concern is the distance between the center line and the top of the compound here. Now let me just go ahead and take the tool post. So ultimately this is going to sit in a block that's going to sit here on the tool post holder, and there'll be one facing this direction and one facing this direction. So pretty much no matter what I do, this lug is going to have to sit above the compound rest. Now in this case, let me just take the tool post off of here to make this easier to see. Even if I can set this up so that the block extends beyond the top of the compound in one orientation, then generally the dial indicator facing out the other way is not going to be able to avoid having the tab actually hit this. So the question is, how much clearance do I have over this? Easiest way to find that out is to go ahead and mount this in the chuck. Now, make sure the lathe is off. We're not going to turn anything on. Don't tell anybody I did this, but I'm just going to mount the stem in the jaws of the chuck very, very lightly. Now that way, I know that the center of the dial indicator is on center in the lathe. So when I turn it this direction, I know that the lug on the bottom is sticking down as far vertically as it's going to have to stick when I have this in the tool post holder block centered up on the edge of the spindle. So then the question is, will the compound clear it? Now I can already see that it's not going to, but let me go in here and let's see how close we are. I don't want to actually under, the force of the screw actually hit this. Yep. You can hear that. And it's hitting. So what that means is that we have no ability to make any kind of tool holder that's going to hold it in this orientation using that lug and not have the lug make contact with the compound. So I think what that means is our other real option here is just to take the back with the lug off of it and then use these 4 screw holes to actually hold the indicator into the block, which means we'll design the block with a recess for the body of the indicator and 4 holes in the bottom so we can run screws up through into the indicator to hold it in place. And I think that will just have to work. We don't really have a lot of other options. Suppose we could try to cut that off, but I'm not really interested in doing that. Much easier, just take the screws out, take this off, mount it, and if we ever need it, we can save this and put it back on the indicator later. Okay, there's one last thing that we need before we can go model this tool holder, and that is to get the proper dimensions for the dovetail. Now this is just an extra tool holder that I have for the tool post on the lathe, and we're going to take some measurements of this. Now this has chamfers on the dovetails. I don't know how important that is, and it also has a slight recess in the bottom. Okay, the first thing we need then is the depth of the dovetail, and I've got a depth mic here. That looks like about 384. And then there's a little step on the side, and let me get the measurement of the height of that as well. And that should be a little shallower, and it is. Looks like 382. Now for the width of the dovetail, we're going to do that with pins. So we'll lay a pin in each side of the dovetail and measure the space between them. Now, I don't have two identical pins because I just have a set of gauge pins. So we will use a 250 1/4 inch on one side and a 249 on the other, simply because that's what I have. Now let me take a rough measurement using the caliper just so we know about where we are. And that says 1 inch 7/1000. But I don't want to take that as my measurement. I actually want to use the gauge blocks. So let me find there's a 90, and then let's grab a 107, ring those together and see how close that is. And in fact, that fits pretty close. Let's try a 108. And that will not go in. So the 107 was about right. So between the two pins, 1.007 inches. Now let's try to get that actually a little bit closer. So let's go back to an 80 and 800 thousandths with the 107. And then if we add on a 100 thousandths, that should fit exactly. This should stack up. 800 thousandths plus 100 plus 107 should stack up exactly to fit, and it does. But this will allow me then to add some tenths. So let's add 2 tenths to that by using a 1002 block. And that will go. Let's try adding 2 more tenths. So we're not staying rung together. There we go. And this is 4 tenths. That will not go. Let's try 3. And that will just go. So it's 1.007, 3. Okay, that's about as close as we can measure it. Put the gauge blocks away, and I think we're ready to go into the computer and model this thing. Here we are in Fusion 360. Let's model up a dial indicator holder. I've created a new document and I've saved it. You have to save a document first before you can bring other models into it. So let's bring in the dial indicator that we modeled previously. Now let's look at how this thing is oriented right now. Now I would actually like, put this back to home, I would like the top of the indicator facing positive Z. So I'm going to go ahead and rotate this around 180 degrees. And it's not really necessary, but it just makes it more convenient because the model, when it's done, will have Z in the right direction and I don't have to rotate it if I want to 3D print it or mill it. Click OK. Now, this is just sitting here and it can move around. We need to have an anchor point for the design so that stuff doesn't move. So I will right click on this and say ground. And that will ground this component so that it won't move. Now, unfortunately, you also have to go in and grab the base component within this and ground that as well. Otherwise, if you grab this and try to move it, it'll actually end up moving the individual body or the individual component within the design that was brought in. But with both of those anchored, now they won't move. So I can grab this, it won't move. I can try to grab the lug back, it doesn't move. Now we don't need all of this, so I'm going to go in here and turn off the screws. I'm not going to use those, and I don't need the lug back. I'm just going to use the indicator itself. Okay, now I want two indicators back to back, so let's set that up. I'll click on this, hit Control-C for copy, and hit Control-V for paste. Now, it's pasted the second one in the same space. I just moved it out of the way so you can see that. And now I'm going to hit J for joint, and I'm going to join these together. So I need a reference on each component to join. So I'm going to pick this ring right here, and this ring right here. Now, because I picked the same part on each component, it's going to try to put them together. But I want them facing at opposite directions, so I'll click Flip. And now I have them back to back with those rings I selected right together. Now I'll slide this one over, and I know because I did a little bit of math that I want this to go over 475 thousandths. Now that's not a magic number. What I did was I played around with the calipers and figured out how far these plungers move when the plunger is fully depressed to its stop. And then again, since I used this ring and this ring, how much the little dome sticks out, so that when either one of these plungers is pressed all the way to its stop, there will still be 25 thousandths clearance between the two plungers, so they won't actually strike each other. And that's just why I chose that 475. So now we have these two back to back. This one is grounded, so it can't move, and this one is joined with a rigid joint, so it can't move. So everything here is rigid. I'm clicking and trying to move these, and they don't move. Okay, let's build a body for this indicator holder. Now what I'm going to do is I'm going to go in. You can see there's a little lip on the bottom. So I want to click on this surface right here. This is the part that sticks out the furthest. Right click, create sketch. Now I'm going to project onto these. I'll hit P for project. Click here, and now that will just project lines into that sketch that represent the outside edge of that body. I'm also going to take the very top, the widest part here. I'm going to click that and project it on both sides as well, and click OK. So now I've got these lines projected, and I'm just going to select them all. Just holding Control to multi-select, and I'm going to mark them for construction, because I don't want those to be considered actual lines in the sketch. So now, see, there's more in here, isn't there? Yep, there's multiple lines that got projected in there. I'm not sure why that is. Okay, so those are all constructions. So now you note that when I move the pointer into that region, that isn't an actual profile that's going to be available for extrusion. It's just, those lines are just there for construction. So now I need to create some lines that I'm going to use to extrude the walls. And I don't want the wall of the body of the holder to actually touch this. I want a little bit of clearance. So I'll select this, hit O for offset, and I'm going to give it 25 thousandths. And we do the same thing over here. Click this, hit O for offset, 25 thousandths. Then I want to actually create an offset of this because I'm going to use it for the outside wall. Hit O for offset, and I'm going to move that 20 thousandths. Okay, so now I have my regions around this, and now I want to draw up the rest of the body of the holder. So hit L for line, and I'm just going to sketch a line across here. I'm going to reselect this and make sure those are tangent. Okay, so those are tangent. That line is now black, meaning that it cannot move. And then over here, I want to put in some kind of mirror feature so that I can draw the dovetail and make sure that that's centered. So I'll draw another line over here, mark it for construction. That's just going to be between the centers of those points. And then a line off of the center point here, also marked for construction. so that now I have a mirror line that I can work around. So let's draw the dovetail roughly where this is going to go. It's going to go like this. And then back down tangent to that edge. Now I have no idea if the angles are what I want or if any of this is what I want. So let me dimension some of this. So dimension this angle. I want this to be 60 degrees. And then let's go ahead and mirror this. Sketch, mirror, and mirror all of this around this. Okay, now I do have a few dimensions that I took yesterday. So I know the dimension for the full depth of the dovetail. I know that's 382 thousandths. I don't know the full width of the dovetail though. That was done based on measurements over pins. So let's draw some 3-point circles and draw in the pins that I used. Actually, let's draw a 2-tangent circle. So I'll select these 2 lines, and now I have a tangent circle. And that represents the pins. Now let's actually dimension the pins, because you remember one of them was 1/4 inch, 250, and the other one was 249. And then what I was able to measure was the distance between the pins. And there's a couple of ways I could do this. I could actually construct some lines perpendicular to the base here, construction lines, and then put a dimension between them. But I'm just going to go ahead and put a dimension across between the center of the pins. And this needs to be what we actually measured, 1.0073 thousandths plus half of this pin diameter plus half of this pin diameter divided by 2. And that gives us the actual width of the dovetail, and we have the depth of the dovetail. The one thing that we don't have right now is the position of this thing. And I want to see if I can get this whole thing out of a 2-inch wide piece of aluminum, so I'm going to say 1.975 for the overall width. That will give me that'll give me a width of I can get this with 25 thou to spare, taking off half of it off of each side from a 2-inch wide bar, and I'll be pretty happy with that. Now for these lines over here, why don't we just say 45 degrees? So in this case, the complementary angle 135 degrees. That looks pretty reasonable to me for overall shape. I'm going to do a couple of things here just to make my life easier. Make these construction lines just so that they will not end up defining regions here. Okay, I think that looks pretty good. Now, the thing about this though is when I machine this, I don't want to use a dovetail cutter. I don't like dovetail cutters. If you've watched any of my other videos where I've used dovetail cutters, you'll know why. They're in a CNC machine, they're particularly troublesome. So what I would really like to do is just machine the entire perimeter of this thing with a 1/4 inch tool. And of course, the one thing I can't do here with a 1/4 inch tool is get into the back of this dovetail, obviously because it comes down to a point. I don't want to do another setup. I'd really like to just put the tool in here. So I would like to create space in the back. This dovetail actually registers on this front surface and this inside surface. And so then this back surface is clearance. So there's no reason that this material right back here even has to be here. So I figure, why not open this up and make space for the cutter? So let me create a circle. Let's just put in a circle here and then move it into place. Okay, so what I want to do is have this and this coincident. Can I do that? Yep. And then I want to make that and that tangent. And that puts that circle exactly where I want it to be. And then I'll take a line from someplace, L for line, here over to tangent, and I will then mirror these around our center line, so we have the same thing on, whoops, don't want to mirror the center line, I'll mirror around the center line. So now we have the same thing on both sides. And I'm going to need some dimensions on some of this stuff. Let's pick a figurine here. 6/10, yeah, it looks okay. And then we need a diameter on this. Now I'm going to use a 1/4 inch cutter, so I'm going to say 300 thousandths. And that'll give us some room to run a drill down this initially to clear much of the material, and then be able to bring in a 1/4 inch tool and climb mill around that. So I think that's going to work. Let me do one other thing. Let me put a chamfer across here. I think that does it. Let's extrude. So I'm going to pick holding control and picking all of these regions to extrude. I'm going to extrude this direction. I'm going to go to object, and I want to pick a point on this ridge, but I want to offset let's say 50 thousandths, just to give myself a little bit of clearance so it won't actually collide. Okay, that gives us the main body around the indicators, but of course not attached to them. Let's put a base on it, so I will just create a sketch here. And you don't actually have to put anything in it. That will just give you a space where you'll have these regions that are defined. So now I've selected all of those regions, right click, extrude, and let's go down 3/8 of an inch. Okay, so now if we look at this from the top, if I turn off the dial indicators, you can see that we've got a basic body here that has space around it for the dial indicators, for the dial indicator bodies to sit into it. There's obviously some other issues here, but I would like this to come up all the way to the top. So let's right click here, create a sketch, and I'm going to project these regions around the top again. Okay, and then make those for construction, and then offset them as before. Now this is a knurled surface, so I'm going to say 30 thou because I'd like to be able to rotate this easily. Like this one, O for offset, 0.030. Okay, and let's extrude that up, and we want to go distance to object, and we need to pick a point on the very top edge here. So that's going to bring that up. Okay, that looks good. Now I can drop out the indicators. You can see we've got a pocket with a little ledge there to make room for the bezel. Now obviously these are not going to be any good being sharp. Hit F for fillet, select all of those, and say 100 thousandths. That looks good. Okay. I think that is going to work. Last thing we need up here is a hole for the adjustment screw. Draw a construction line off of the midpoint. Give that a length. I think I want that 244 from the side, and that's a dimension that I had from measuring the existing one. And let's create a hole there. Create hole, add a single point, and what do we want here? We want a tapped hole with an angled bottom, and let's do this 375, so it's going to be 3/8 24, which is a standard adjustment thread. How deep do we want that to go? 3/8 of an inch deep. And I'm going to model the thread so that when I 3D print it, there will be threads in the hole. Okay. That's the hole for the adjustment screw. The next thing we need to do is create some space here on the end for the we need to make space for the indicator to go through. Obviously the back of the indicator, if I turn off the body here, these stems have to go through, so they're going to have clearance. So let me create a sketch. Easiest place is probably just right here. Okay, project outside of this stem and the top of the part. Okay, now let's look directly at that. Now this, I want this to actually be a construction line. And then I want to offset that. Let's give it 20 thou clearance. And let's take lines from the top down. I want that tangent, horizon, snapping tangent. Okay, that'll work. So what I'm doing is I'm coming in, touching the center of the circle, and then dragging out. I'm not pressing any buttons. And that gives me that line and automatically lines me up horizontal to it. And so then when I go straight up to here, now I get a perfectly perpendicular line. So I can stop that, select, let me turn off these. And I just need to select all of these regions. And extrude. And we'll just take that all the way through and cut all the way through. Okay. And that gives us clearance through the body for the dial indicator. So I can turn those back on. And we can see that that is going to work. Let's just check to be sure. So I select that surface, say inspect section analysis, and that gives me a section plane that I can drag through and see how that's all going to fit. You can see we've got clearance all the way around the indicator, clearance around the stems. That looks really good. Okay, I think we now need some mounting holes for the screws. So let's create a sketch on the bottom. Now to get the mounting positions for these screws, I am just going to turn off the body here, and I am going to project all of these screw holes from the bottom of the indicator. Okay. I'm just going to go around and select all of those as well. And mark those for construction so they won't define regions. Okay, I'm going to turn the body back on here, and then I want to put some circles around these things. So I'm just hitting C for circle, and I'm going to put 2 circles around each of these, one for the countersink and one for the actual through hole. And we'll constrain these in a moment. Okay, so I'm going to just select all of the inner circles and mark them as equal. And then I'm going to select all of the outer circles and mark them as equal. And this way we only have to dimension them once. Now let's dimension these holes. So D for dimension, I'll select this inner one, and these are going to be M2 screws, and so a clearance hole for that is 2.4 millimeter. So I'll just go ahead and type that in metric, 2.4 millimeter for the inside, and I'm going to make the hole for the countersink with a 1/4 inch end mill, so 0.25. And that gives us that. Okay, stop that. And now let's make some holes. Let's actually put the holes in here. These profiles are going to be difficult to select, aren't they? So this is the clearance hole. We'll just extrude it all the way through. It did go all the way through, right? Yep. And then we'll of course have to turn the sketch back on. And then to extrude the countersink, I'll just register all of these, select all of these regions, profiles, right-click extrude, and we'll run those in, and I want the screw to grip a good 3.5 millimeters into the indicator, and I'm going to use a 10 millimeter screw, which means I need this to be 6.5 millimeters of web thickness. So I'll just say to object, select the bottom of this, and offset minus 6.5 millimeter. And that will give me what I want. Turn the sketch back off. Okay, I think that is just about it. Okay, I think the last thing I'd like to do here is just smooth over some of these edges. Let me select a couple of these. Let me put fillets on those. Yeah, those are nice and round now. And then let's put some chamfers in a few places. There, there, there. Not going to try to chamfer this. This is actually a lip that's going to be underneath the bezel anyway. Go around all of these because we can. I don't want to put the chamfers actually inside the dovetail because I'd like to keep support on the dovetail as close as I can to the top and bottom. And let's say 25 thousandths. Yeah, that looks pretty good. Okay, well, I am happy with that. Save it, and let's send that to the 3D printer. I'm printing this part with PETG filament. ABS or PLA might be a better choice just in terms of material for use in the shop, because they tend to come out a little more dimensionally accurate, at least on my printer. But this is a fairly wide part with a lot of structure above a wide base, and that can lead to a lot of warping if you use a material with a lot of shrink. PETG doesn't really shrink very much, so that makes it a lot better in this kind of application. And since it's just a prototype, it'll be fine. PETG is more flexible though, and that means that the part probably won't be totally suitable for use in the shop since the pressure from the tool post will cause it to kind of warp and twist. It'll bend a lot more easily than ABS, which again is still going to bend, or PLA, which is actually more likely to crack under that kind of a pressure. But as a prototype to validate the design, this should be just fine. As soon as this is done, we'll go back out into the shop, mount the indicators, and make sure everything fits before we actually start cutting metal. Okay, I have the printed part here. Let's mount some indicators. So I've got the backs off of the indicators, so with the holes exposed, and I've got the holes cleaned out, support material out of the holes here. So I should be able to just drop this in and put in the screws. Okay, now that they're all in, let me just snug them down. No need to go too crazy. Well, that's pretty nice. And the stems don't touch. They come within 25 thou of touching about, which is what I intended. They sit nice and flush. I can get at the bezel to turn it. That's pretty nice. Last thing is the height adjustment screw. And I have the appropriate set screw here. Now these threads were just printed. They were not, I haven't run a tap through it or anything. They're just in there as they were 3D printed. And let's see how this goes. Now it's starting. I can feel it turning. It's probably gone down about 4 threads. Let me grab a wrench and finish it up. Well, that's pretty nice. It's starting to get tight as it's in, I don't know. Yep, there's the bottom. Well, I'm happy with that. This print ended up being a little bit rough. There's something going on I need to tune on the printer, but overall, I like it. Let's go try it on the lathe. Well, here's the block with the dial indicators mounted. I've got the jack screw in here, but I don't have a height adjuster on here. We'll need to make one of those before we use this in anger. But let's see how it fits. Let's see, it does fit on the dovetail. It is a little bit tight. I'm kind of looking at the print quality here, and there are some artifacts kind of in the print that could be causing that. This is pretty typical with 3D print for the plastic to expand a little bit. I think that's probably going to be fine. Now you can see when I do this, or maybe you can't see when I do this, but the plastic is actually stretching. This plastic is too flexible really for this application. But as far as the fit goes there, I think this is going to work. We can go ahead and make one in aluminum, and if it's too tight, we can always shave the dovetails a little bit, even with a dovetail cutter. Let's see if we can get in, see if this is really going to work to reach what we need to reach. Got it more or less on center here. Just got a piece of stock in here. I just threw this, and of course this is not a 4-jaw, this is a 3-jaw, but this just illustrates the point. Looks like I've got about 0.02 total indicated run out there. It's not bad. What about clearance to get in here around the jaws? Can we get in close? Yeah, that's pretty good. I could always angle the tool post block and get in a little bit closer, but it looks like we haven't added much bulk over the actual size of the indicator itself, so that works okay. What about the face? Trying to hit the camera here. We want to dial in a face. Again, the dovetail's a little tight. Well, that's pretty nice. The needle is twitching there. Not much, that's pretty accurate. You can see it is moving, it is live. So we can reach down to this shoulder. Yeah, a little bit more, maybe half a thou run out there. Well, I think this is going to work. The next step will be to make one of these out of aluminum, and we will start on that next time. If you are enjoying these videos or find them useful, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.